Important rules about significant digits, also known as significant figures, sometimes called sig-digs, sig-figs. Number one, all measured digits plus one estimated digit are considered significant. So if I wanted to measure the length of this model Pan Am 747 plane fuselage, I'd put my meter stick or my ruler up against it, and I'd look as carefully as I could, and I'd notice that it's in between 10.2 centimeters and 10.3 centimeters. I can clearly see that, but I am going to have to estimate what it means to be in between 10.2 and 10.3. So I'm going to call this 10.25 centimeters in length. And so what that means is my measurement of 10.25 centimeters now has 1, 2, 3 known digits to known accuracy and one digit that is estimated, but the grand total is 4 significant digits. Now regarding zeros, if there's a zero in the measurement that's between two digits, that zero is considered significant. So in the case of this wooden horse, its mass was measured and the mass was found to be 107 grams. And those 107 grams, that measurement has a zero in between the 1 and the 7. Well, no matter that it's a zero, that doesn't matter at all. It's significant. So therefore, there are 3 significant digits in this mass measurement. In the next situation regarding zeros, they may be trailing with no decimal place, and that leaves an ambiguous situation because we don't really know how accurate the measurement was. In the case of this metal block, its mass was measured and found to be 200 grams. The question is, are all 3 of those digits significant? How do we know? We don't know. There is one possibility where we can write the 200 grams, of course. We can put this bar over the last digit here, and that indicates that there are 3 significant digits. Likewise, if someone were to have written 200 grams with the bar over the middle digit, we would know that the measurement is accurate to 2 significant digits. So sometimes you will see these, but it's really most common and by convention most commonly done to write this in scientific notation. So if I want to indicate the number of digits that are significant, I would write 2.00 times 10 to the second grams, and that indicates that all 3 of these digits are significant. So here we have 3 significant digits, whereas up here we also had 3 significant digits, but here we just had 2 significant digits. And again, using scientific notation is the best way to indicate automatically the number of significant digits and the accuracy of a measurement. And for the last note on significant digits, if a trailing zero comes after a decimal, that zero is considered significant. So here's some examples let's talk about. First of all, 5.00 times 10 to the second milliliters. Well, because these zeros come after a decimal, they're considered significant. So in this first example, there are 3 significant digits. In this example, 7.0 grams, the zero comes after a decimal, the trailing zero is after a decimal. That is a way of indicating that there are 2 significant digits in that measurement. In this third example, 36.40 kilograms, again, this zero, it's a trailing zero, but it comes after the decimal point, so that is a total of 4 significant digits. Now, in this example down here, we don't know whether there are 1, 2, 3, 4, 5, or if there are only 4 significant digits here. How many kilowatts? Well, 53,270 kilowatts is that 4 or 5 significant digits. And the best way to indicate, the best way to show the accuracy of the measurement or indicate number of significant digits is to put this into scientific notation. So 5.3270 times 10 to the 4th kilowatts shows us that there are 5 significant digits.